Now we shall discuss a concept which is known as isometric length. So what do you mean by an isometric length? So in this last front view of problem number 4.1, as I have mentioned in the earlier sessions, each of these edges, they are having a length reduction, and the actual length was 50 mm. So initially when we started with the diagram in a simple front view and top view, or in the actual case the edge length is 50 mm. So when it comes to the last front view, each and every edges, they have got a length reduction. So each of this length, so this length, this is not the actual length of the cube, this is a reduced length, and usually we'll be calling this length as isometric length. So how to calculate this isometric length trigonometrically, that is what we are going to discuss now. So I have drawn the last front view separately here. So this is the last front view, I have drawn it separately here. So in this case, what I have done is, I have constructed a square. So this edge length, this is 50 mm. So if you measure it, this is a 50 mm, and this one, that is d dash a dash, is same as that of d dash a dash here. So I have constructed a square, and this red square, it is having an edge length of 50 mm. That is the initial original dimension. And as this is a square, this angle will be 45. And as I have mentioned earlier, this angle is 30 degrees. So this is 30 degree and this is 45 degree. So this length is known as the actual length, and this length is known as the isometric length. So the actual length is denoted as d dash e in this diagram, and the isometric length is mentioned as d dash a dash in this diagram. So what we are going to calculate is, we have to find out what is the value of d dash a dash trigonometrically. So if you measure this edge length directly, you will be getting it approximately as 41. So how to calculate it trigonometrically? So that is what we are going to discuss now. We shall consider this diagram. So in this diagram, you consider two triangles. The first triangle is d dash e g. So this totally it is a triangle, and the second triangle is d dash a dash g. So this is the second triangle. So the first triangle, this angle is 45, and in the second triangle, this angle is 30. So for both of them, this angle remains the same, and that is 90 degree. So we shall do a trigonometric calculation here. So what I have done here is, I have enlarged this area alone. So this area, so that is d dash e g. So this triangle, and d dash a dash g. So this small triangle, I have taken this area separately outside. So this is, so I have made an enlarged version of the same for a better understanding. So this is d dash e g. So this is the first triangle. So the length over here, we shall call it as true length, and the second triangle is d dash a dash g. So this is the second triangle, and the angle between this line, and I have got a reference line here. So this reference line is same as that of d dash g here. So this is 45 degree and this is 30 degree. So you consider these two triangles. So we shall calculate the value of cos 30. So what is the value of cos 30? So cos means it is adjacent side by hypotenuse, is it? So cos 30 is adjacent side, that is d dash g divided by d dash a dash. So d dash g divided by d dash a dash, and cos 45 is equal to d dash g divided by d dash e. So this is cos 30 and this is cos 45. So along these triangles, d dash e is representing the true length and d dash a dash is representing the isometric length. Our aim is to calculate the isometric length trigonometrically. Okay, so we shall have a ratio of cos 30 divided by cos 45. So cos 30 divided by cos 45 is equal to d dash g dash divided by d dash a dash multiplied by d dash e divided by d dash g dash. So these two will be cancelling each other. So finally it will be d dash e divided by d dash a dash. So d dash e is equal to d dash e is equal to true length, and d dash a dash is equal to isometric length. So true length divided by isometric length is equal to cos 30 divided by cos 45, or else we can write it as isometric length divided by true length. We are just taking the inverse. Isometric length divided by true length is equal to cos 45 divided by cos 30. So we can calculate cos 45 divided by cos 30 using calculator. It is approximately equal to 0.816. So it is approximately equal to 0.816. So you can even take it as 0.82. So from this equation, what is isometric length? Isometric length is 0.816 into true length. Okay, or else we can write isometric length is equal to 0.82. We are just approximating this value into true length. So this is the value of isometric length. So it is equal to 0.816 into true length, or else it is 0.82 into true length. So let us refer the previous problem. In this previous problem, initially the true length was 50. So when you multiply this 50 into 0.82, you will be getting the approximate value as 41. So that is how all these edge length, they are foreshortened to a measurement of 41 approximately.